question that everyone asks here or everyone is confused about is Hadoop is meant for what or for whom? To be very frank, Hadoop is a technology where people from different background can contribute. For example, if you're a Java developer, you do have lots to contribute when it comes to Hadoop. If you are from SAP, if you have SAP plus Hadoop, believe me, you are a hot cake in market. Now, apart from that, even if you are not aware much about technologies and you have basic understanding of data, when I say data, it's not only RDBMS, any type of data, unstructured data or structured data, you still have things to contribute in Hadoop, right? And if you see the rate with which market is adopting Hadoop in near future, you will find lots of opportunities also in market, right? So what we'll do, we'll first understand the problem, what problem is there in industry, and then we will position Hadoop as solution, and we will see in brief how actually we can get going with Hadoop. When it comes to prerequisites, whether you meet prerequisites or you don't meet prerequisites, you need not worry about it, because we will provide you a prerequisite session where we will take up Linux basics, we will take up Java basics as it comes into the picture, right? So we are going to ensure that you have all the prerequisites, right? When it comes to what should be the nature of data, Hadoop is meant for all type of data, whether it is structured, whether it is RDBMS based, whether it is ETL data, or whether it is coming from any diversified source. Hadoop provides a common architecture to handle all those type of data in order to ensure that whatever problems are there when you actually go and handle data in projects where you have huge volume, variety, and diversification of data. Not only diversification from point of view of format, but also diversification from point of view of source of data where it is created, right? Fine. So let's start. If you all know, right, today we are living in data age, right? And it is very difficult to measure total volume of data which is being stored electronically, right? But there are bodies which actually keeps on creating estimates on data, and finally they observe that the chunk of a volume of data which is coming is creating actually a digital universe, right? And if you see forecast, volume of data which will be managed in enterprises will grow up to almost, you say, 2 zettabyte, which is equal to 10 raised to the power 21 bytes. So if you, in other words, you need not worry about these units which I'm talking about. You need to just understand that huge of data will be too much, right? Fine. Now, what are the sources of data which are coming? Now, if you just take up some samples, if you know New York Stock Exchange, now it generates around 1 terabyte of data per day. Very near to you is Facebook. Now, Facebook approximately have 10 billion photos, right? Taking up their storage capability to 1 petabyte, right? Now, similarly, you will have lots of applications where volume of data will be too huge, right? Now, when I say volume of data is too huge, what is the problem? Because capacity or storage capacity of hard drives are increasing massively over years in order to meet need of the industry. But what about speed? The way capacity is increasing of hard drive with the same rate, if you see, a reading capability is not up to the mark, right? So if you see, one typical drive can store terabyte of data, but in order to read, you will have lots of time which your processors will take in order to read that same volume of data, right? So what is the first problem that we have identified here? First problem is how to match volume with the rate of retrieval, right? So this is what is the first problem which industry got. Now, second important problem, what about if a hardware fails? If you have stored data on a disk and if that hardware fails, where actually you have single disk or multi-disk using various technologies like RAID and all, right? What happens? You will be losing important piece of information, and today no enterprise can afford losing information, right? So second important problem here is we need a reliable system so that we will not lose data in case if a hardware fails, right? So looking into these two important problems, something was needed in industry, okay? And as a result of which if you see Google, they started doing research, and when they started doing research, they found that volume of data which they have to index and prompt to the user as a search result is growing daily, right? On a daily basis it is growing. So they need to adopt an architecture where problem of retrieval, indexing can be sorted out, and this actually gave birth to Hadoop, right? So what is Hadoop in short? You can say Hadoop is an architectural element that helps you to manage huge volume of data, providing more reliability, right? And it is independent of structure of data. In other words, it will not bother about whether your data is structured or it is unstructured, whether it is coming from RDBMS, right? And it takes responsibility of improving seek time, right? And it provides you capability of exploiting all your commodity hardware. You need not go for you say sophisticated hardware where you will be taking AIX from IBM or various data storage hardwares which are provided by various companies, right? So this is what is overall objective of Hadoop. Fine. So if you see, I feel that my presentation is there in front of you. What we will do, we'll just have a look over graph in order to better define Hadoop. Let's go here, and if you see now here, volume of data has increased from megabyte to gigabyte, terabyte to petabyte. Apart from that, variety of data also increases, like companies are handling various type of data, and that data is pretty complex. So complexity is increasing, variety is increasing, and volume is increasing, right? So in order to ensure that you are able to manage, yeah, Vipul, that's what I'm coming to. I told you diversified source of data. When we say diversified source of data, it means it can be structured data in form of tuples which are stored in databases. It can be unstructured data, right? In terms of you say pictures, in terms of text files, in form of CSV file, in form of Excel, in form of any variety of data. Hadoop is capable of handling all different type of data. Yeah, Vipul, I'll just answer it. In order to help you in getting data from your RDBMS and put it on top of Hadoop, you will have some tool like Scoop, right? So that's what I will tell you. Hadoop has an ecosystem where you have small tools which we use in order to extract, load, and transform data. Okay, so RDBMS can also be a contributor of data to your Hadoop, for which you will be using a tool. Okay, that tool I told you is Scoop. Is that clear, Vipul?
Yes.
Okay. So you when we say variety of data, that itself includes all different type of data. Whatever is the source and whatever is the nature of data, Hadoop provides you its capability, because at the end of the day, Hadoop is there to provide you a reliable system which saves you from data loss. Hadoop is there to provide you better access rate through its adopted principles. Fine. So if you see here, volume of data increases, complexity increasing, variety of data is increasing, and this is the reason why many people will have questions that what nature of data Hadoop handles. So please understand, Hadoop is capable of handling any type of data, right? Fine. Now if you see, what are the drivers of big data? Now if you see, you will have processing of two types, right? One is interactive processing, second is batch processing, right? These two type of processing you will be doing or you will need when you go and access data, right? In interactive, you will be adopting a solution. For batch, you will be adopting some other solution. Now when it comes to Hadoop, Hadoop provides you batch, right? Hadoop believes in batch processing, right? In other words, it will gather data which is scattered over Hadoop ecosystem or Hadoop file system, and then it will take it up and use the data for analysis, right? Yeah, Ashraf, I'll maximize the presentation. Fine. So now if you see, what are the drivers of big data? You have business, opportunity to enable innovative business models, potential for new insight that drives competitive advantage. Then you have technical data collected and stored continuously to grow, right? Data is increasingly everywhere in many formats. If you see here, variety is coming, volume is coming, and then traditional solutions are falling under new requirements. Why? Because most of them which are created keeping in mind interactive retrieval of data, right? Then comes financial reasons. Cost of data system is increasing. This is the reason why Hadoop said that you need not buy complex hardware. What you can do is you can install Hadoop, you can set up Hadoop on commodity hardware, right? Simple hardware where you will have some disk and you can use combined power of that disk in order to explore it, right? Cost decreases because Hadoop is an open source software as well. Is that clear? Is that clear, right? What drives big data? Cost, volume, variety, right? And diversified, you can say diversified data. So all these problems which are there can be handled by Hadoop itself. Right. Now, let's move and talk about what Hadoop is. We have lots of other problems which we will talk in forthcoming sessions when we will try to resolve it using Hadoop practically, right? Now, you see, Hadoop is a library, right? Contributed by Google. You can say Google wrote white papers and Google adopted a particular system, and then later they made it open source, which was adopted by Hadoop. So basic Hadoop is contribution made by Google to Apache, and once that contribution was made, various implementations of Hadoop came up. Out of them, one is Cloudera, then you have MapR, then you have HornetWorks, right? You have various implementations today in market, right? Now it is designed to scale up single servers to thousands of machines, where each machine will offer local computation and storage. This also you will be seeing shortly once we move forward, right? So in short, what is Hadoop? Hadoop is an open source library which is there in order to help you to manage huge volume of data. Okay, Peter, can you mute few people who are unmuted? Okay, Peter, can you mute please, because I think we are getting some background noise. Okay, fine. Now if you see, does Hadoop handle only cloud data? See, here we need to understand that data need not necessarily be on cloud, right? Data can be there within your enterprise and it can be there with your stakeholders. So what you can do, you can use Hadoop outside cloud as well. Wherever you feel that volume of data now is becoming huge, retrieval rate is going down, you can go and you can implement Hadoop. Apart from that, you can also have Hadoop on top of your cloud solution. Okay, is that clear, Deepa? So actually cloud provides you the infrastructure where you will keep your resources, right? So you can use Hadoop in order to exploit resources which are there on cloud as well. Okay, I'll be showing you one demo once it comes to that particular level. Yeah, Ashraf, can it be set on VMs? Yes, 100%, and that is what we will also be doing. Okay, how can Hadoop understand unstructured data? Hadoop can understand unstructured data because Hadoop has those components which provides capability of taking up unstructured data, splitting it into various blocks, and then have capability of gathering it and reconstructing it. Okay, so you need not worry, Sachin, we are going to take up that as well in forthcoming sessions. Okay, just in order to provide you this information, Hadoop has infrastructure or Hadoop has capability of splitting the data and then regathering it. Okay, so how it does that, all we will see. Is that clear? Fine. Now if you see, objective of this basic demo today is we will see how to configure Hadoop, we will see where actually Hadoop is implemented, right? Some case studies which implements Hadoop, and we will understand very important component of Hadoop which provides reliability and which actually takes responsibility of increasing the access rate It's a file system, virtual file system called as HDFS. Okay, so these are the components that we will be talking in this particular demo, right? Fine. So I feel that these three terminologies are clear to you all: variety, volume, right, and diversification of data. Right. So if these three things are clear, then we can move and we can talk about Hadoop explicitly. I'll be showing you how to configure Hadoop also, and we will be providing you all technical help in order to ensure that Hadoop runs on your machine as well. Okay. Now Hadoop is not like traditional application in hardware architecture. Obvious, Hadoop applications looks like more batch jobs, right? It's clear. So Hadoop primarily has adopted batch algorithms in order to provide access to data, right? So batch jobs used to calculate bills or transform data from a database into a data warehouse. Now, second important thing, Hadoop takes a chunk of data, does something to it, and sticks it somewhere else for another application to process, right? And that is done on a massive scale in Hadoop, right? Hadoop is based on distributed computing, so it uses lots of commodity hardware for processing the data at same time. In other words, assume that you have a huge file. Now what Hadoop does, Hadoop will split that file into n number of small blocks, and it will store 3 copies of block on commodity hardware. Now whenever access will be required using a particular algorithm which is adopted by a component of Hadoop called as MapReduce, it will go, it will gather that data, reorganize that data, and return that data to whoever has requested for it. Okay, it's clear. So what is basic principle? What happens when you actually ask your Hadoop to store the data and provide access to it? Whenever you go and place any data, structured or unstructured data, on Hadoop file system, it splits it in n number of blocks and ensures that for reliability it is making various copies of it and keeping it on different hardwares, right? Advantage, if one hardware fails, that same data can be picked up from elsewhere where it has stored its copy, right? This is what is basic principle how actually Hadoop works, right? So if you see, Hadoop spreads data processing logic across thousands of commodity servers, and these server nodes are grouped into racks. Now if I talk about what is the architecture, architecture is very simple. You will have rack, right? So first unit is rack. Inside rack you will have nodes. Now one node can represent one system. Inside node you will have hard disks, right? And in hard disk you will have data. Is that clear? What is the architecture? Racks. Inside racks you will have nodes. Inside nodes you will have disk. Now one node can have 4 disks, 5 disks, 7 disks. Other node can have 2 disks, 3 disks, right? And on top of this rack or combination of racks, you will have Hadoop file system installed, which abstracts user of Hadoop from the actual hardware. So when you place your request to store a particular data or a file or data coming from SAP or ERP or various other sources, that Hadoop takes responsibility of taking that data, splitting it into blocks, creating n number of copies, by default 3 copies, and scattering it on the entire hardware. It also ensures that data, when it scatters or when it stores on nodes present on different racks. So if your entire rack also fails, still data will be recoverable from other racks. Okay, is that clear? Yeah, Vipul, installation I will tell you, don't worry. Fine. So this is how actually Hadoop works. So I feel that you all got an idea like how actually Hadoop works, right? So let's come to directly to components which are there in Hadoop. See, basically Hadoop is complete ecosystem, right? But if I say core Hadoop is made up of 2 components. One is its popular file system called as HDFS, and second one is logic unit, or you say a unit that provides you capability of going and getting the data from Hadoop. It's called as MapReduce, right? So
If I say Hadoop is equal to HDFS plus MapReduce, it defines entire Hadoop. Okay. Now what is this HDFS? Now if you see, HDFS is a file system which actually abstracts your file systems which are stored, which are present on nodes, right? HDFS takes responsibility of splitting the data, putting it on different nodes, replicating it and managing it. Okay, so it's an abstract file system which ensures that it is keeping track of all racks. Okay, so when I go and install Hadoop, while installation of Hadoop, I configure racks, I configure nodes, and I specify what all disks are there on that particular node. Right now, like other file systems, HDFS will also organize your information in blocks. Okay, so what is block? You can say block is the storage unit provided to you by HDFS. Right now, if you see Apache Hadoop distribution, default size is 64 MB. Okay, this is file block which is there on HDFS. But native operating system will have very small block size, that is 512 KB. Right? Is that clear? What is size of a Hadoop block? Default size of Hadoop block? It's 64 MB. Okay, so assume that you have a file of 200, or you say you have a file of 200 MB. Now what Hadoop will do? It will split that particular file into n number of 64 MB blocks. It will replicate it and it will go and put it in the file system. And that file system represents what? N number of racks. On that racks you will have n number of nodes. Inside each node you can have n number of disks. Is that clear? Okay. What is the difference between cluster and node? Sammy, I'll come back to that, but just in order to tell you, cluster is collection of n number of nodes, Sammy. Okay. What is basic objective of cluster? Basic objective of cluster is failover and load management or workload management, right? So when we talk about HDFS, by default HDFS is a clustered file system, right? This is the reason why it is able to split your file, create 3 copy and replicate it on various nodes, so that if one node is down, other node provides the data.
I have a different question. So you mentioned that file blocks are going to be 64 MB and storage blocks are going to be 512 KB. So on HDFS, each node, what will be the actual block size? As to my understanding, it should be 64 MB of each block.
It is configurable. We can configure that, but by default, if you go with Apache Hadoop, it is 64 MB. But you can configure it. I'll show you the configuration files also, where you can specify your block size.
You mentioned 5 and 2 KB. What was that?
This 512 KB is the block size of storage. Okay. So you can say the 64 MB is made up of n number of 512 KBs.
All right. Okay. I got it.
Okay. Advantage, if you see here, when you go and seek data, instead of seeking data in unit of 512 KB, you will be able to seek 64 MB at the same time. Okay. Okay. Fine. Now Deepa is asking question, does it also extracts besides splitting and managing data? Yes, it will do that. For that only you have various tools in Hadoop ecosystem. For example, you will be using Scoop in order to extract data from database and put it on HDFS. Is that clear, Deepa? Okay, fine. So let's move. Right. Now, how HDFS works? Just a small sample. I tried being very simple so that people from diversified background are able to understand, right? Even if you are not from Java background, or you say SAP background or RDBMS background, I tried my level best to simplify the content. Right now, Hadoop is made up of you say HDFS, and HDFS organizes your nodes into 2 different types. Okay, in short, HDFS has 2 different type of nodes. Very simple. NameNode, right? NameNode is the master node, And if you see what is responsibility of NameNode, responsibility of NameNode is to keep track of all data nodes, right? So you might have understood the minute I said data node will store your data, right? NameNode will not store any data. Data will be stored actually where? On data node, right? NameNode will just maintain, you say, metadata about what block is stored where, right? Is that clear? So if you see, you have NameNode master, and if you are putting two files, you say data1.txt, data2.txt, right? Here it is divided into n number of blocks, right? 1, 2, 3, because size of data1.txt makes your HDFS create 3 blocks of 64 MB, right? Now if you see what it will do, your NameNode will allocate storage to your file on various data nodes, right? These all are data nodes. Now what HDFS does, the minute you put any file on HDFS file system or copy a file from local file system to HDFS file system, your NameNode takes responsibility, reads that data, identifies how many blocks it has to create, and then stores those blocks on various data nodes, right? So if you see here, data1.txt has 3 different blocks, and it is stored on how many data nodes? 1 is here, 1 is here, and 1 is here. 3 copies. 2 is here, 2 is here, 2 is here. 3 copies, right? Then data2.txt 4, 5. Again 4 is there, 4 is here, 4 is here, 5 is here, 5 is here, 5 is here. So 3 copies is what is by default maintained. Now number of replicated copies, if you want to increase or if you want to decrease, that you can do by setting up it in a file called as HDFS-How. I'll show you that, and parameter is dfs.replication. So how many replicas need to be created, that is also configurable. You can configure and you can ask your HDFS to create those many of replicas, right? Is that clear? What happens when you put files from your local system to any other system, or to a local system to HDFS, right? Now, one very important question. Who will decide? Assume that you have 100 data nodes, which are also called as slaves. Who will decide that on what data node data should go or block should go? This intelligence is there with NameNode. Okay, NameNode identifies best possible data nodes where actually data should be stored. Is that clear? Okay, fine. And all this is automated. You need not worry. Right. Now question is, why 3 copies? 3 copies, I feel that you might have got answer. What if main, okay, Vishnu is asking a very good question, that is, what if main node will fail? See, this is what is single point of failure, NameNode. But what you can do is, with recent versions of Hadoop, you can maintain 2 NameNodes, okay, and you can identify mode also, active, passive. Now what happens when active is down? Passive will take over, right? And continuous synchronization and replication of metadata will be done between those 2 NameNodes. Is that clear? NameNode is a virtual name, yes, but responsibility of NameNode is different from responsibility of data node. Data node takes responsibility of providing the actual storage. NameNode takes responsibility of identifying where actually, on what data node, what should be stored. Rather, you can say NameNode takes responsibility of passing out the information to the job tracker, which is again a component you will see. Okay, you can have n number of people. It depends what architecture you want, right? Fine. So why 3 copies? Very simple. What if one data node goes down? Now how actually your NameNode will come to know that one of the data node is down? This is also simple, because all data nodes will keep on sending heartbeat to NameNode. If NameNode is not receiving heartbeat, you say for 10 seconds, it will assume that particular data node to be down, and it will start using rest of the data node. Is that clear? clear, right? Fine. Now, respanning. If one data node is down, master has to maintain the right number of replicas in order to do that. It will do what? For example, assume that you have stored your file here. You just I'll come back here. If you have stored your block here 1 1 1 2 2 2. Now what happens if this node is down? If this node is down, what happens? The replica that it needs to maintain is 3, but since this data node is down, number of replicas will be 2, right? So your NameNode does what? It respans, recreates those data nodes, you say data blocks, and allocates that data block to another existing data node. Is that clear? Robert, Sachin, is that clear? I need prompts, then only I'll understand that yes, you all are there and I'm audible. Otherwise, sometimes because of network issue, we'll get disconnected and you will not listen anything and I'll keep on speaking. Yes, data gets copied, right? It respans that data and copies it on other data node.
So, I have a question.
Yeah.
You're talking about this, the nodes, right? We put the capacity that Hadoop has got 64 MB as the
block.
That implements 64 MB and storage block per cycle KB.
Yeah.
So whatever you showed in this replica, is it all about Apache? Is what you're referring to here?
Yes, this is Apache and replicas are copies. It ensures that it always has 3 copies. I was not able to hear your question actually because some noise was there at your end.
Okay. So I was checking like this slide that you're showing 9 out of 65. The representation of this diagram here. So the each block 1, 2, 3, 4, 5 they are the storage blocks, right?
Yeah, they are storage block. You see, to be very simple, data1.txt is copied from local file system to HDFS. HDFS takes responsibility of dividing it into data blocks, right? So data1.txt, depending on the size, has 3 blocks of 64 MB.
So how would that data be split into the equal number of blocks, like 1, 2, 3?
It is not equal number of blocks. If, for example, if assume that you have 140 MB of data in the file, right? So what it will do, 64 plus 64 plus third block will contain whatever is left over.
So it is first in first out, is it? So the data, the integrity, how is it maintained from?
Yes, integrity. I told you one term called as scatter and gather. Okay, so it scatters it. While scattering it, it ensures that it puts the signature so that when it recollects data, it is able to recollect all blocks of that particular file. So definitely that block will have file ID. You all know that when you go and store file in file system, internally it will have an ID allocated to it, right? fstat. There is a structure called as fstat. That structure contains complete information about that file. So this fstat is attached to each data node, each block.
Okay.
Okay.
So will this vary? This block size vary with the 512 MB, 512 KB storage block size? Will it vary with the type of variety of data we get, like unstructured, like format can be like video files and all those things?
Yeah, right. It will vary. Yeah, people said that since it's all just wrapper of Hadoop. Okay. Yeah, all these flavors are implemented using Apache Hadoop. Sachin and people. Okay. So Cloudera, MapR, Hortonwork. Once you are aware about Apache, and in our course, what we have is we work with Apache Hadoop, but we ensure that we are completing Cloudera and at least 2 implementations. So Cloudera definitely is one of them because maximum market share is of that. But believe me, once you understand Apache Hadoop, working on any distribution will be easy for you because core remains the same.
And what about this IBM Big Insights? Do they also play?
That is also implementation of Apache Hadoop. that see all companies have come up with their own implementations of Hadoop. IBM has that big insight, then you have Cloudera, then you have Hortonworks, which is a team which came out of Yahoo and they created, and Microsoft is taking help of Hortonworks in order to build their own Hadoop ecosystem. So HP has its own. So almost all companies are coming up with their own implementations. But yes, core remains the same. HDFS is common. Commands that you use on HDFS is common. What is different is various tools which they provide in order to make life of administrator and developers easy. Okay,
Gotcha.
fine. So I feel that this is also clear. Write 3 copies, right? Right. Now if you see, this is what is architecture at Yahoo. I will most of the things I have already told you in the beginning itself, but just see, you have 8 core switches to switch to help your you say NameNode switch from one rack to other rack. 100 racks, 40 slave per rack. It means each rack will have 40 nodes. What nodes? Data nodes, because slave is data node, master is NameNode. Now 1 gigabit in rack, 10 gigabit between racks. This is what is the speed of transfer. Total amount of data which this architecture is managing is 11 petabytes. Okay, so here you have rack. This is what is rack. Then you have master node, right? 64 gigs. Then you have slave nodes. All these are slave nodes in rack 1. Is that clear? This is what is architecture. So if I'll ask you to build your architecture, what you will do? Rack, inside rack slaves and master, right? And each slave can have a number of them. Don't worry, we'll do all these kind of setup in upcoming sessions, right? Okay, till here it's clear, right? Fine. Now if you see one very important feature of NameNode, NameNode is rack aware, right? When we say NameNode is rack aware, it means NameNode has intelligence of selecting the right rack and data node on that particular rack where replica has to be placed, right? So NameNode understands which rack contains what data node, right? Replication happens smartly. Now why I am saying that replication happens smartly, there is a very important reason behind it, and let's go and explore it. Now if you see here, take up a case. NameNode splits data in a number of blocks, and what it is doing, it is storing blocks on data nodes present on the same rack. If that rack is down, then what? Entire data will be lost, right? Because all replicas are there on the same rack. So NameNode ensures when it is going and storing the block, it uses data nodes which are present on different nodes, different racks. Okay, is that clear? And the smartness is there with your NameNode. Algorithm is written for your NameNode. You have to just configure your NameNode so that it's aware about what all racks are there and on what rack what data nodes are configured. So if someone is asking you that is the NameNode rack aware, yes it is. What benefit you get? I feel that you can specify the benefit that we discussed. It will ensure that it is not storing all blocks on data nodes present in the same rack. It will distribute across different racks. Is that clear? Fine. So it's preparing HDFS, right? Okay. Now take up a case. You are writing files using copy to HDFS cluster. I will talk about all these commands. Now since it is demo session, I am just trying to make you feel that what is benefit of Hadoop, and industry is going to adopt, lots of jobs are going to get created. Now you are writing data to a file. See what happens. This is client. Client wants to store a file, right? So client will ask, I want to write file.txt block A. Okay. NameNode will say, okay, write it on this data node which is present here. Okay, and these are the data nodes where you have to write. It's clear? Data node 1, data node 7, data node 9, which are present on different racks. So whenever you will use any interface to write your file to Hadoop file system, your NameNode will take responsibility of telling you that see, you can go and store here, because NameNode is not going to store data. It is just going to manage the entire file system, right? So he will tell store it here, and then client will go and store on those data nodes. It's clear? So I feel that if you will write a Java program in order to write data to file system, what will be responsibility of NameNode is clear to you. NameNode will tell you back about the places where you have to, where you can write the data. Okay, fine. So you'll come to know about pipeline write later once we move. Now comes read. Okay, because these are operations which are common in almost all systems. Now client wants to read data instead of writing, right? What are the blocks locations for results.txt? NameNode will listen to it and he will tell that see, blocks which makes up results text.txt are stored here. Your block A or first block is there on these data nodes, block B is there on these data nodes, right? It's clear? And it will ensure that it is providing you addresses smartly ordered, right? Whatever is nearest to you, that is what will be the first one, and if that first one is not having, you will move to second one. If second one is not having, you will move to third one. So it provides you an ordered list so that client can look up for those blocks at appropriate nodes. Is that clear? These are blocks. Yes, right, Deepa. Your results.txt have two blocks, block A and block B. Rather, you can say that your results.txt is split into two blocks, A and B, and these are the places where they were stored. So when client is asking, yeah, data nodes, okay, we don't use different terminology this now, because when we move to Hadoop, let's talk in terms of Hadoop terminology. Why? Because in interviews, if you will go and if you will try to use other terminology, though meaning for you might be similar, but it may be different for the interviewer, right? So try to adopt terminologies which are Hadoop based. Okay, data set has a different meaning in Hadoop. Is that clear to everyone? What will happen when you will write a client program and ask him to give you file? Client program that you will write using Java or various other technologies will place request to NameNode. That NameNode will tell where all blocks are stored. You will go, you will read those blocks, right? And you will you'll get the file. It's clear, right? So I feel that what is the role of HDFS is clear to you. HDFS has name node, secondary name node, and then it has data nodes. Actual storage will be there in data node. Name node will contain complete metadata about files. They are stored on what block, they are divided into what block, those blocks are stored where, right? What need to be done if one node is down, respanning need to be done, and then further that respanned block need to be stored on other nodes. Okay, right. Now let's come to second important component, and this second important component is MapReduce, right? This provides you analytic or analysis capability, right? Once HDFS has stored the data, you can go and do analysis of the data, and you can gather data, apply different algorithms to transform the data in the form you want. Okay, so if you see, for that they provided MapReduce, right? The second component, MapReduce, processes data on each node in parallel and calculates the result of the job. There is also a mechanism to help manage data processing tasks, right? So as of now, since it is demo, you should understand that MapReduce actually is combination of two processes. One is map, second is reduce. Okay, what map does? First, the file gets split up on the HDFS, then all participating nodes go through the same map computation for their local data set. They count number of times words will show up, right? In order to help you in understanding, let me take an example. Okay, now if you see, you have a file called bigdata.txt. Okay, and it is stored. Okay, it contains these keywords. You are typing Hadoop, big data, green plum, and various others, right? You are writing something. This is there. You are submitting it to HDFS. HDFS has stored it in various data nodes present on various racks. Okay. Now, when you go with map phase will do what? It will count how many times this word called big data has come in the file. How many times Hadoop has come, right? So it will go and pick up blocks from each data node and it will keep the count. So you can say this is what is the count of, you say, content which appears in a file in this block, which is stored on this. Then second block, you say second block is there here. Here count is 9, 8, 6. Third block count is 3, 4, 9. Right. So when bigdata.txt is a huge file, 64 MB, 64 MB, 64 MB. In that 64 MB, occurrence of big data letter or word is 7 times, green plum is 5 times, Hadoop is 4 times. On second data node, which contains another block of the same file, number of occurrences are these. On third, number of occurrences are these. Right. So in short, map phase will generate a key and value. Big data is the key. Number of times of occurrence is 7. Right. You can say this is word count program. Then green plum, number of times in this block which is stored on this data node, first data node is 5. Hadoop, number of times is 4. So basically your map phase provides you a key value pair of each block stored on data node, right? Then comes second phase. Second phase is reduce phase. In reduce phase, what will happen? You will go and you will get an aggregate of all blocks along with the total number of storage. If you see all those maps which you have seen in map phase, big data 7 plus 9 plus 3, 19 times. Reduce gives you 19. Same is the case with green plum, 5 plus 8 plus 4, right, gives you 17. Hadoop, 4 plus 6 plus 9, 19 times, right. This is what is done in reduce phase. Is that clear? So you will be writing map reduce program, obviously using Java, but there are various other interfaces like Hive, Pig available for non-Java developers as well. People from SQL background, they love using Hive, and just to tell you, Hive is used in Facebook. Okay, Pig is used in Yahoo, and all these will do what? At the end of the day, they will translate or they will convert your script into map reduce jobs. So clear to everyone?
Yep.
Right. Now we'll come to Hadoop architecture. See, if you see here, you have data node, right? Components will be data node, name node. Apart from that, you will have various other components. For example, client, whenever he will make requests to execute something, that request will be made using map reduce, right? Name node will create a job, and that job will be submitted to data nodes. Okay. Each data node will have a task tracker, right, to which actually job tracker will talk to. For example, you are interested in storing file, right? Name node goes there, creates a job. Job tracker passes on information decided by name node, who all are going to store the data, and this task tracker will take responsibility of actually storing the data. Okay, so we will come and know more details on this once we are in actual sessions, right? Now I'll just go and show you the Hadoop ecosystem, and if you see, these are various providers. We have Cloudera, DataStax, EMC has its own Hadoop, Hortonworks, IBM has its own, Mapr, Datameter, right? All these are various products which are there, but all are built on top of Apache Hadoop. And if you see here, market share, Cloudera leads, Hortonworks, IBM, Mapr. This is the reason why we decided that we'll be covering Cloudera and Hortonworks. Okay, because maximum market share is of these two. So first actually we go through Apache Hadoop, and then we ensure that people are up with Hadoop using Cloudera as well as Hortonworks, so that they can be part of that market which is maximum. Okay, is this clear? Fine. So this all details we will be seeing in forthcoming sessions. Hadoop case studies, you can know more where all it is used at this particular site. I'll just take you there. If you see alphabetical list, you'll come to know who is using for what. Okay. For example, Babacar, we use Hadoop for searching and analysis, right? Using Hadoop for log analysis, data mining, and machine learning, right? So actually, we also prepare our case studies from here, looking into industry and what they are using and what form they are using it, right? So you have various users who have already ported their data on Hadoop. Okay, you have a huge list. You can go through it whenever you are free. It's clear. I need prompt because now we are going to start up with setting up Hadoop. Okay, before we dive, we'll just go and see how Hadoop is installed. Okay, is that fine till here? Okay, right. How to install Hadoop. Now we will have virtual machine which I will share with you all also. I'll guide you how to install. For example, I have installed one virtual machine here, on top of which we have installed and can install Hadoop, right? So though we can install Hadoop on Windows, Mac as well as Linux, but in production it is always there on Linux, right? You can use Windows Hadoop to be a client to HDFS. Okay, so better is to go through that. I'll just enter admin user, right? I'm there here. This is a virtual machine. I'll be helping you in first session for installation and setting up your Hadoop itself, right? Now, for example, if you want to set up Hadoop, what you have to do? See, Hadoop installation consists of HDFS node, job tracker, and worker node, right? What we will do? We will download Hadoop. Okay. For example, I have downloaded Hadoop. I'll just go. I'll maximize this, switch to full screen so that I can show you how to set up Hadoop. I'll go here and I'll go to terminal, right? And I'll see ls. Now, if you see, you have to download this. Okay. In order to download, you can simply go and write here google.com. Yes, Ashraf, it is. That's what I told you, that you can have Hadoop on various operating systems. Okay, but in production, most of the companies have it on Linux-based platforms. Okay, it's taking time. Because I'm in VM. Right. In short, you have to download Hadoop. Once you will download, you will get it in your downloads folder. For example, I'll just go to downloads, and once you download, you will get Hadoop downloaded. Okay, clear. You will get the tar file. You have to just go and do what? Unzip it. Okay, how to unzip? Right click, unzip, or extract, or use tar utility on Unix. I'll be showing all that to you, but assume that you have downloaded and you have extracted. Once you will extract, you will get this directory structure. Okay, this is what is the directory which contains all binaries and conf files related to Hadoop configuration. So let me go there. Some more admin tasks are there to prepare your Linux so that you can host Hadoop on top of that. That I will be doing along with you, right? I'll go and I'll do ls. This is what is the directory structure where you have bin. Okay, you have conf.
which contains config files. So let's go to conf, do ls, and if you see, you have various configuration files, right? Important ones here are HDFS site file, core site, and for MapReduce you have MapRed site.xml, right? These are the important configuration files which you have to configure. Okay, is that clear? Fine. So I'll come back here. Now assume that what I am doing here is I am going to cd bin and I am trying to start. To start, you will have, I'll just go here, one sec. Go to bin ls, and you have here various programs like start all. When you say start all, it starts all utilities or all components of Hadoop, right? Let's go and try it. I have not configured it, so it should not start. See, name node, data node, job tracker, task tracker, all this will start. Okay. This is Linux. I will help you in setting up Linux on Windows also. Don't worry. Now if you see, I just wrote here start all, and it is starting data node, secondary node, right? It's already running, so we can stop it, and then we can start. I feel you got right. Once it is installed, you will be able to start. Let me see what all processes are running. And if you see here, you will have NameNode, you will have job tracker, you will have, yeah, Ubuntu. Vipul, it is Ubuntu. Yeah, I'll tell you. See, there are various versions of, you can say there are various architectures of Hadoop. You can have standalone Hadoop, you can have clustered Hadoop, right? So what needs to be done when you go and set up Hadoop on a cluster? What configuration you have to do on a master, and what configurations you have to do on slave? All that I'll be telling you in upcoming sessions, Vipul. I'll ensure that you are able to set up a cluster, right? And that too in 1-2 sessions itself. Okay, fine. So we have here these services which are running. NameNode, data node. We have only one data node, so only one task tracker. Whenever client will submit job, NameNode will delegate it to job tracker, and the job tracker will take responsibility of talking to the right task tracker. You have here one secondary node, NameNode. Now please understand that this secondary NameNode is not failover node. This just keeps copy of metadata which is there on NameNode, so that once NameNode is down, it is easy for you to recover. Okay, is this clear? Fine. Now once your Hadoop starts, you can start working with Hadoop, right? But since we are yet not done with installation on your systems and all, which I will be doing along with you in forthcoming sessions, just wanted to show you that we will do everything practically. Okay, I'll just go here and I'm going to this. If you see, once your Hadoop starts, it will give you the console, right? And now this is a small web console which is provided to you by Apache Hadoop itself. Cloudera and all will have better options. Okay, for example, I'll browse the file system. Now if you see, this is what is content of my HDFS, right? It is not, if I do ls here, you will get content of the local file system, right? But this is displaying what? File system of your Hadoop. Okay, so for example, you can use file system here, right? It's not configured properly. I'll be doing it with you. But here, if you see, admin console is there. Yeah, DFS or FS also works. Data in. This is what is one of the files which is there. Okay. It depends on version, Vipul. DFS older version, new version FS also works. Okay.
now you have Hive directory and all which is created, right? I'll be talking to you in detail when it comes to how to manage HDFS file system. Okay, so since it is demo session, we will just be constrained to what all we are going to take, because I need to take your questions also regarding coverage and all. I'll just go back here, and if you see, we will follow instructions one by one, right? You have to set up Hadoop home, name and all. I'll talk about that. Install SSH, generate key, copy key, in order to ensure that no password is required actually to start your Hadoop processes. Okay, then make dir, and then these are the directories which you have to make. Name and data. Data will contain content or metadata about data which are blocks. Change the permission, right? All these are steps that will be following. In NameNode, change the directory. Place IP address of all slave nodes in the Hadoop conf slaves, right? So assume that you want to set. This is what is important file. HDFS master node 9000 is the URL. And then here, if you see HDFS site.xml, you are specifying that your Hadoop file system or HDFS will be stored or will store data on in what local directory. Okay, so you'll have Hadoop data dir where actually your files will be. And here you see dfs.replication, number of replicas that you want to create. Then you have mapred, you are specifying the job tracker and its port where it should run. It's running on what? Master node, right? Now apart from then, once it is done, you will format it. After formatting, you will start up with start all.sh, right? And then we will have a complete session on, you say, HDFS as well, right? Now where you will specify that whom all this particular name node will talk to. For that, we'll go to config file once again. Here we'll go to Hadoop. I have to maximize. Just go here. And if you see, this is what is your Hadoop. In this you have conf, and in this you will have slaves. Now assume that this Hadoop installation you want to treat as master. You can go and you can specify here. Okay, who all are the masters? See, I have only one master, so localhost is what I have specified. So if in your cluster you have more, just specify those IP addresses here. Okay. Similarly, you can specify who all are the slaves, like data nodes are there. As of now, it is localhost because it is there on same PC. Otherwise, what you can do, you can go press enter, specify IP address of whatever is there in your network which you want to treat as slave. So it will have a list of all nodes where actually you are maintaining your data nodes. Is that clear? Okay. Then you have SSL client, you have SSL server for SSL handshake, you have matrix properties, right? And one of the important one is Hadoop env.sh, where you can specify what Java you want your Hadoop to use, because Hadoop is written in what? Java. So whenever you start Hadoop, it will always launch Java processes. On one machine you can have more than one JDK, right? So it becomes important for you to specify that you want to use what, right? You can also specify heap size for your Hadoop, right, and other options. Is this clear? Okay, so we will be talking about this in greater detail once we start with actual session, right? Now what I want you to do is you have to put questions if you have any. We will maintain proper labs here for each topic that we are going to deal, but before that I will like to tell you what all components we are going to handle. Okay,
you can inform it to Peter. Okay, we are going to talk about various components, and those components are simple, like you will be using Hive, they will be using Pig, right? We will be using all these products which are there in front of you, right? Hive, Pig for non-Java developers, right, who are not aware of Java or good in Java. Eclipse for Java developers, where we will be writing our own MapReduce, right? HBase, it provides you interactive. Instead of batch, if you want to get data in interactive mode from Hadoop, you can use HBase. AVRO is used for serialization, and Zookeeper is used as a manager for your task. Right, so these are some of them. Apart from that, we will also go through Scoop, which provides you access to RDBMS. Right here, if you see Avro, serialization, Zookeeper, Coordinator, HBase, ColumnDB, MapReduce, Pig, and which is used with ETL tools. Right, so these are various components which we will get into. Right, after we are done with Apache Hadoop core, we will go with various implementations. Okay, right, we will go with various implementations, which includes Cloudera, which includes Hortonworks, which includes, you say, MapR, right? So I'll try to make you up with various commercial implementation of Hadoop itself, right?